Hello and welcome back. Today I will guide you through the process of how SSH Authentication works. You've done extensive research and read various documents but still struggle to grasp the concepts. Or perhaps you're looking to understand the concepts of public key and private key. Okay, let's see. Here we have a user. I will draw a line here to represent it. We now have an SSH client, which is indicated by a green line. And finally, you can see the GitHub with the black line. The first step is for the user to initiate the SSH connection. This is done by running a command like ssh-git@github.com in the terminal. This command tells the SSH client that the user wants to establish a secure connection with GitHub. Following the initiation, the SSH client sends a connection request to GitHub. This step is essentially the SSH client reaching out and saying, "Hey, GitHub, I would like to start a secure session with you." GitHub then responds to the connection request by sending a public key challenge to the SSH client. This challenge consists of random data encrypted with the user public key, which GitHub already has on a file. The purpose of this challenge is to verify the identity of the user. As you can see, GitHub uses the public key to encrypt the data. To decrypt the challenge received from GitHub, the SSH client needs access to the user private key. If the private key is stored in a standard location like sudo/.ssh/id_RSA on a Unix client system and has the correct permission, the SSH client automatically retrieves it. Here is an example of how the permission should look using the ls-la command for both the SSH directory and the private key file. The SSH directory has 700 permissions, meaning only the owner can read, write, and execute within this directory. The private key file has 600 permissions, meaning only the owner can read and write this file. The public key file typically has 644 permission, allowing it to be readable by others but not writable. One small thing to remember: if the key is protected by a passphrase, the SSH client will prompt the user to enter the passphrase to unlock the key. Once the private key is accessible, whether retrieved automatically or unlocked by the user, it will be used to decrypt the random data sent by GitHub, proving the user identity. With the private key in hand, the SSH client decrypts the challenge is received from GitHub. Successfully decrypting this data demonstrates that the SSH client owns the correct private key associated with the user's public key. Next, the SSH client sends the decrypted challenge back to GitHub. This step acts as a proof to GitHub that the user has the correct private key, thereby validating their identity. Upon receiving the decrypted data, GitHub verifies it against the original random data it sent. If the decrypted data matches the original, GitHub confirms that the SSH client has the correct private key and thus the user is authenticated. Once the verification is successful, GitHub sends an authentication success message to the SSH client. This message indicates that the user has been successfully authenticated and that the secure connection has been approved. Finally, the SSH client informs the user that the connection to GitHub has been successfully established. At this point, the user can securely interact with GitHub over the SSH connection. And that's it. We've walked through the entire SSH authentication process step by step. I hope this helps you understand how SSH authentication works. If you enjoy the content, please consider liking and subscribing to our channel. Your support means a lot. Thanks for watching and see you in the next video.